All right, so we've started recording, and let me share the screen. I'll share that with you. Right, all I can see is me, which is wonderful. I want to reduce that down. I don't want to hear any background noise at all. So take a look at that. This is about correlation and scatter diagrams. I'll be referring to your book later because I'll call up this camera facility that you know all about. You know about this camera thing. Where is she? Yeah, her. So I'll be working with her in a moment. But for now, look at the screen. If you plot some coordinates which describe a relationship between one quantity and another, we can see if there is in fact a relationship between these two quantities. The proper word for the word quantity is a variable. Can you see for now that whatever we're plotting, they seem to go up together? Yes or no? Okay, so that's called a positive correlation. Whatever quantity goes up is also going up here in the y direction. Likewise, here, this quantity is going up while this quantity is coming down. Is that okay? That's called a negative correlation. And it's not surprising that when you plot two sets of other data with two different variables, you could get coordinates all over the place. What's the relationship like between this variable and that variable? Looking at that. Equal. Is there a relationship between that and that, do you think? Yes or no? It says no correlation. What does that mean? Nothing whatsoever. Let me give you this. Sorry? True, because it's not that and it's not that. It's all over the place. There's no relation whatsoever. Let me give you some examples. Look at this. If there's a positive correlation, you can pick up your ruler and draw a lovely line of best fit through the points. Can you see that? And then you can read off one quantity and the other. Right, whoever's talking needs to stop. If there is a negative correlation, you can draw a lovely straight line graph to show the relationship. There? Yeah? Okay. If there is no correlation whatsoever, where do you draw a line of best fit? Answer? Fantastic. Was that you, Ella? Good. Yeah, there's no relationship whatsoever. So how can you say, oh, the relationship is positive, the relationship is negative? There is no relationship, there is no correlation between these two variables. Is that fair? Okay, thanks, Viraj. Let's move on. Look at this. I downloaded this. It's trying to show the relationship with the weight of a student and that the marks they get on their science exam. Please describe that relationship. Thank you. Is that you? Is that you, Ian? Who was that? And who's me? V-chip. Okay. So Viraj, there is no correlation whatsoever. So in other words, really skinny little boys or skinny little girls don't get a low mark, and really, 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 really fat kids don't get a high mark. Yeah. Oh, Ella, have you come out?
Yeah.
Oh. Of course you can. You should do, really. You really should do, yeah. I don't know why you're on your phone. So have you got that, kids? There is no correlation. In fact, let me write that, and hopefully this will work better because there's no video in the way. So there's no link at all between your weight and your performance in any exam. No correlation. Let's turn over the page. What about that? What do you see? Let me write that now. It went right over there, okay. But let me write across there. So I have to go across here then, there we go. So positive correlation, correlation, a relationship together. Now, somebody describe the story you see on the graph. So what goes up when the temperature goes up? Does that make sense in everyday life? Okay. So here's a different question. I want to make good use of this. If the temperature is 22 degrees C, how many ice creams would you expect to sell? How would you do that? How did you do that? Well, let's do it. So if you're in an exam, you've got to do this. And I'm going to try and do it in front of you with my line facility. That's 22 degrees, thereabouts. I'm trying to get it right. And then you turn left and you read that temperature. Now, I'm doing this with a mouse. It's really hard. You've got rulers and pencils. So, and again, I didn't quite get it bang on 22. But can you see the way you show that work? You show it by starting on 22, saying to the examiner, arrow up, arrow left, and that looks more like 73 degrees. 73 sold. Is that okay? So if you said 72 and you're reading this off the screen, that's absolutely fine. But in an exam, you've got to show it. Now I'm going way beyond year 7 now. Okay, this is GCSE grade 5 because being able to draw a line of best fit and interpret it and read off it is grade 5. Simple. This is grade 5 GCSE that we're doing right now. Are you okay with positive correlation and the fact you can read off a graph? Can I move on? All right. So I don't know if you recognise this, but this kind of graphic is, I took a screenshot on correlation and scatter diagrams from MyMaths. Yeah? I don't know if you've ever logged into MyMaths, but there's a massive amount of questions there, and there's teaching tutorials. So I did one of these, and I downloaded and pasted the graphic of the screenshot. So what's this story about? What's it about? Very good. An art exam, maths exams. And what is the relationship between the maths exam result and the art exam result? It's a negative correlation. Yeah, absolutely right. Now, I drew in this line of best fit. Yeah, use line of best fit to help you. Okay, they drew it in. At least you know how to draw a line of best fit. Aim through the middle of the points. And then it says a student scored exactly 40 marks in their maths test. How much are they likely to have scored in their art test? So again, line of best fit is drawn. I went 40 up, hit the line and turn left. I put 60 in the box and I clicked mark it and I got it right. Is that okay? Now, this only works if there is a line of best fit. You can't estimate from a whole load of points, even though there will be a correlation, positive and negative. You can't do any estimate unless you draw in a line of best fit, and that gives you grade 5 GCSE in this topic. Can we move on? Again, this is going on YouTube as soon as I can do it, so you can study at your own leisure. Again, it's another one I downloaded from somewhere. This is weight and height of children. This is completely real. It's not even made up. Describe, did I use the word variable before today? Yes, I did, because the height of a child, a tree, a plant can vary. The weight of a height, the weight of something can vary. So these are two variables that could be in relationship. Somebody describe that relationship. Positive what? Thank you. So I'm going to write that down. Positive relationship. As one goes up, the other goes up. Does that make sense in everyday life? I mean, as children get taller, they're probably going to get heavier as well because they're growing up. Does that make sense? All right. So let's move on from that and see what we got. Again, this is great. This is year 9 concepts. Somebody describe what you see there. You know there must be a correlation because the line of best fit has been drawn. Do you think that's a strong link or a weak link? I'd say it's definitely weak because look how spread out the results are. So it's a negative correlation, but it's very weak. So what's the relationship? It seems that the more kilometers you run per week, the lighter you're going to get. Does that make sort of sense? Because if you're carrying a lot of weight, or if you only run maybe 1 kilometer a week, then you're going to put on weight and be a big guy. If you're going to run lots of kilometers a week, you're going to shed your pounds and you're going to be lighter in weight. But as you can see, the results are really spread out and not everyone fits that pattern. Do you notice this arrow pointing to that result there? Can you see that? Can you see that point just there? Yeah. That is called an outlier. Why do you think it's called an outlier? Yeah, that's really good, Viraj. It's outside of the normal expected data range. If that blue dot was over here somewhere, you'd think no problem. Now this person, what's his story? What's his situation exactly? But it's still quite heavy, yeah? Now 90 isn't heavy, right? These are probably kids, right? It's not heavy at all. But yeah, he's running a lot but not losing much weight, which means he's probably going home and eating 6 dinners. He's starving, yeah? Or something like that. Yeah, that's a good joke. That's going on YouTube, by the way. And you mustn't tell your mum or dad because I'll get arrested. Remember, that's another joke as well. So yeah, outlier. So I don't know if these results are real, but anyway, this guy is doing a lot of exercise weekly, not losing any weight. So that's that. Let's see the next page. That's the next topic. Lovely. Well, let me just reduce this down and call this up for the moment. Where's that camera gone? Let's look at our book, shall we? So if you go to page 241, are you on page 241? Good. Again, don't stay in audio at the moment. Let's do this together. Positive or negative correlation? Positive or negative? Positive or negative? So Jordan was caught by that. That's got no relation. There's dots everywhere. No, it's your fault, not my fault. Okay, no correlation. Next one. Right, here we go. Look at number 2. Well, he wants, yeah, obviously, but he wants more than that. It's more advanced question. Now read the English to me, someone, from question 2. Right. Thanks, Chioki. I think that's you, was it? Explain what it means. That is a negative correlation. You all said that. Now this says used car value, and this says used car mileage. So someone explain using a sentence what that graph actually shows us. Yeah. Really? So as the mileage increases, the value of the car increases? Going down, isn't it? So as the mileage goes up, the value of the car goes down. That's why it's a negative correlation. This next one, what's that say? Time spent each day doing what? Oh, time spent reading each day. And your shoe size. Explain that, please. As? Your shoe size doesn't affect how much you read, and the amount that you read is not reflected in your shoe size. In other words, if you've got size 23 feet, which is huge, it's like halfway across the maths room, you read like 1,000 books a week. No relationship, all right? Next one. Race distance and world record time. This is a bit of a strange one. It confused my year 7s last year, and it's confusing me now. It's a pretty strong correlation, yes? Positive? Yeah? Someone describe what that means that you can see. Tell me again. Okay, I can't hear you. If you want to speak, come close to your mic. It's not a car. We are world record time. I think we're running. It's a distance, yeah? It's not a car race. It's like a running race. I told you it's quite confusing. Yeah. Yeah, the long, yeah, because if you're going to run a longer distance, it's going to take more time to run it. Fair? Yeah, it's a world record time, so these are fast times. So if you do a short 60-meter sprint indoors, then it's going to be a very, very short time in which to finish, well under 10 seconds. If you're going to do a 100-meter race, then you'll finish around about 10 seconds world record. 200 meters, 400 meters, 1500 meters. Clearly, the longer the race distance, the longer also is the world record time. Is that fair? Okay, now be careful. You have to say this in English as well. Let's start question 3, then I'll leave you soon. Look at question 3. Now, I've got to match A, B, C, D, E with the 3 different graphs and explain it. It's really the extension to question 2. Shoe size and glove size. That one or that one or that one. Which is it? So you're saying there's no correlation between your shoe size and your glove size? I'm saying there is. I'm going for that one. Yeah, if you've got smaller hands, you're going to have a smaller shoe size, aren't you? I know you don't put your gloves on your feet normally, but shoe size, well, no, it's going to be 1 because as my shoe size increases, so will my glove size, because as my hands grow, so do my feet. Imagine a little kid with little feet and little hands, then that kid becomes a bigger kid with bigger feet and bigger hands. That's a positive correlation. That's why it's extension, yeah? Got to think about that one. So this is what I'm going to say you need to do right now as your lesson. You need to do question 1 on exercise 1, page 241. You need to draw it roughly, just as a rough sketch, and then say positive, negative, no. And then you need to do question 2, just a rough sketch, and say negative, no, positive, and explain what it means. And here, I suggest you don't have to draw this anymore. Here, just go shoe size and glove size, positive correlation. As the shoe size increases, so does someone's glove size. Is that fair? Do you understand that? Okay, so let's put your cameras back on now. Camera back on, so I can say goodbye to you all.